All right, so now we are going to find the Maclaurin series of f of x equals e to the x. And in this case, for the Maclaurin series, x equals a equals 0. So we'll be evaluating at 0. Now, first take the derivative of the function. So f prime x is e to the x. Then second derivative also will be e to the x. Third derivative will be e to the x, and so on. Now, we know that the Maclaurin series for that function f of x equals e to the x will be c0 plus c1x plus c2x squared, and so on, isn't it? All right, so we know that c0 is the zero derivative evaluated at 0 over 0 factorial, right? So that means the value of the function at 0 over 0 factorial. So value of the function at 0 is e to the 0, and 0 factorial is 1. So you got c0 is 1. So you plug it here. Next, we'll be going for c1. c1 will be f1 at 0 over 1 factorial. So f1, as you know, is just f prime 0 over 1. And f prime is e to the x, so it will be e to the 0, then it is again 1. So I'm getting just 1x. And if you continue like this in the second derivative also, you see c2 f double prime, that is also e to the x. It is giving you 1 over 2 factorial. So the next will be x squared over 2 factorial, then x to the 3 over 3 factorial, and so on. So that is your Maclaurin series for e to the x. Now you will see what is the benefit of knowing Maclaurin series of e to the x. We'll see in the next example. So now we are going to find the Maclaurin series of f of x equals 6x squared e to the negative 3x. Okay, so how you do that? First of all, look at here. The Maclaurin series for f of x is summation and goes from 0 to infinity x to the n over n factorial. So when I'm having f of x is 6x squared e to the negative 3x. So first of all, e to the x compared with e to the negative 3x. So you need to replace your x by negative 3x. So you're writing here 6x squared summation and goes from 0 to infinity negative 3x to the n over n factorial. And then we do some simplifications. You can keep your summation and then other terms put inside. So first of all, you can write negative 1 to the n, or you can say negative 3 to the n, doesn't matter. Then I have x to the n plus 2, because I have another x squared term in here, divided by n factorial times I have a constant 6. You can put it here or you can put it in the front, doesn't matter. So that exactly gives me the Maclaurin series of complicated function 6x squared e to the negative 3x very easily following the expansion of e to the x. All right.